Assalamu alaikum, Aruj here, and today I will briefly present our project on Maria B, focusing on its supply chain structure, retail performance, and demand forecasting. Maria B operates 40 retail outlets across 15 cities, supported by a centralized warehouse in Lahore, with Lahore, Karachi, and Islamabad contributing nearly 80% of total sales. Moving towards EDA, it showed strong growth in 2025, driven by store expansion and improved retail presence. Emporium Mall Lahore emerged as the top performing store, followed by Dolman Mall Karachi and Centaurus Mall Islamabad. Stitched and unstitched clothing dominate revenue, while luxury categories perform well in value but are event driven. Stores operate at 50 to 70% capacity utilization, highlighting inventory allocation and replenishment gaps, especially outside Lahore. Lead times rise to 25 to 36 days for distant cities, directly impacting the sales performance. If I talk about the process flow of our project, it followed a structured data driven process. We began by identifying operational bottlenecks through interviews and store level observations. Based on this, our objective was to optimize network efficiency and improve demand planning. We collected sales, store, inventory, logistics, and cost data, mapped the design to retail process, and analyzed retail operations such as footfall and conversion, and evaluated warehouse lead times and store capacity utilization. Implemented CAT boost regression due to its ability to handle high cardinality retail data. After multiple experiments, the best performing model used month, shop, and line item as variables, achieving 95% of explanatory power with an average monthly error of only 48 units. This model is reliable for budgeting, inventory planning, and store level forecasting.
If we talk about network designing, then we choose for the optimization model, and you can see that there is a current situation, and we have currently pain points like we have a delivery delay time which is 2.2 days, and we have customer satisfaction score which is 84%, and customer service level which is 85.9%. And for us, key question was, should we operate with the central warehouse or should we go for other two warehouses to reduce our delivery time and to improve the customer satisfaction level as well. So our approach was to optimization model, in which we used our retail network data, and we had our cost like fixed cost and variable cost and warehouse capacities as well. And then we did scenario analysis for all available options like Lahore only, Lahore plus Islamabad, Lahore plus Karachi, and Lahore with all other two warehouses as well. And the impact of this scenario analysis was we had our current baseline, and then we have our optimal solution, where you can see that there is a reduction in delivery time which was reduced from 2.2 days to 1.6 days, and we improved our customer satisfaction level and service scorecard as well. And right now we have our this back storage capacities as well, where you can see that Lahore is utilizing 28% of their total storage, and Karachi 14%, and Islamabad is standing at 10.3%. And then we made our comparisons with the delivery time, where you can see that there is a huge difference. Like our 10 outlets are showing 0.5 day delivery, and then 2.2 to 1.6 days average delivery time, and customer satisfaction points improve by 5%. And see that there is a huge financial impact, like revenue uplift is 7.7 million and additional monthly cost is 636,000 rupees. But overall, there is a huge uplift in revenue, and it is one of the suitable option for us to go for the hybrid model as well, just like central warehouse, and then we have our two more warehouses, one in Islamabad and one is Karachi. And our recommendation is that we should implement three warehouse network. One is for Lahore, second one is Karachi, and third one is Islamabad. But for the implementation, we choose to adopt in three phases. Like phase one is for Karachi, and then phase two is for Islamabad, and phase three is to monitor and optimize this option. Now I will take over to Sherban.
So over here we have the causal loop diagram, which explains how real-world factors influence retail sales. We see two reinforcing loops. The first loop shows how marketing investment increases brand awareness, which drives customer footfall and conversion rates, leading to higher sales. Higher sales then justify even more marketing spend, reinforcing growth. The second reinforcing loop focuses on customer experience. When customers find well-matched product categories and have a positive in-store experience, they're more likely to make repeat purchases, creating sustained demand. Seasonality also plays an important role. During periods like Eid and winter, footfall increases significantly. This triggers strong promotions and creates demand spikes. However, there are also balancing loops. As sales increase, inventory levels fall, leading to stockouts that limit further sales. Similarly, higher discounts can boost volume in the short term but pressure margins in the long term, influencing both footfall and conversion rates. Overall, this model shows how sales emerge from demand drivers while being constrained by operational limits, forming a strong foundation for demand forecasting. Then we conducted the QSIM analysis at Al Fateh VMall style code. We applied tracking signals at the store and line item level to distinguish random forecast errors from actual demand bias. For most categories such as jewelry, leftover, M basics, and stitch, forecast errors fluctuate around zero and cumulative sums show no sustained trend. M kit shows mostly positive errors, and M luggage shows mostly consistently large positive errors, with a sharply rising cumulative sum indicating significant underforecasting and a high risk of stockouts. In conclusion, the results show that demand behavior varies by category, highlighting the importance of line item specific forecasting rather than a single uniform model. One key limitation is that QSIM must be applied one store and one item at a time, which limits store comparison and increases analysis time.